assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Right, this problem is asking us to find the maximum angular speed of a wheel that has an angular amplitude of pi rad and a period of 0.5 seconds. Since this is still simple harmonic motion, we can write the equation for displacement as theta at time t equals our angular amplitude cosine of omega t. And we also know that omega can also be written as 2 pi over t. So we can substitute that in, giving us angular amplitude times cosine of 2 pi time over period. Right, and we're trying to find our angular velocity, and so we can use the equation velocity equals negative 2 pi over t times our angular amplitude sine 2 pi t over t, which will give us, since when angular velocity is at its maximum, the cosine is at a value of 1, we can actually simplify this even further to just velocity equals 2 pi angular amplitude over our period. So substituting these values in, we have that our velocity is 2 pi times pi rad, because that was our angular amplitude, divided by 0.500 seconds, giving us a value of 39.5 rads per second. The second part of the question is asking us to determine the angular speed at displacement pi divided by 2 rad. So we have a displacement of pi divided by 2. We still have the amplitude of pi divided by 2 rad. And then we have the amplitude of pi rad. And we can substitute this value in to find out what is our value for our cosine 2 pi t over t. So if I plug in these values, I have pi divided by 2 equals pi cosine 2 pi t divided by t. And solving for cosine 2 pi t divided by t, I end up getting that term, 2 pi times the time divided by the period, is actually going to equal 1/2. We also have that sine squared of a position plus the cosine squared of that position is going to equal 1, which allows us to then solve for the value of our position in terms of the sine function. So what that looks like is I would end up having sine of 2 pi t over period is going to be equal to the square root of 1 minus cosine squared 2 pi t over the period, which we already have here is 1/2. So in reality, this is 1 minus 1/2 squared, which gives us an answer of the square root of 3 halves. So now, using my velocity equation, where velocity equals negative 2 pi over my period times my angular amplitude sine of 2 pi at the time divided by the period. I can substitute in my values and get negative 2 pi divided by my period, which is 0.500 seconds, times pi rad times the square root of 3 halves, and that gives a final velocity of negative 34.2 rads per second. And finally, we're asked to find the angular acceleration when the displacement equals pi over 4 rad. So, acceleration, we have the equation acceleration equals negative 2 pi over our period squared times our amplitude, our angular amplitude, cosine of 2 pi times t divided by our period. However, this term right here is our displacement equals our amplitude times the cosine of 2 pi t over t. So we can actually just substitute this amplitude into this equation. So we have acceleration equals negative 2 pi divided by our period squared times our displacement. And we have our displacement as pi divided by 4 rad. So we're able to substitute everything in, and we get our acceleration equals negative 2 pi divided by 0.500 seconds squared times pi over 4, giving us a final acceleration of negative 124 rads per second.